All right, so first thing y'all did was create student objects. Again, to reiterate, they are not JSON objects. They are for your seed file, which just takes plain old JavaScript objects. So for the strings and stuff, double quotes are cool. That's up to your personal preference, but the keys should not have double quotes around them. They should just be the key. Cool? If you did that in your object, go back and fix it so that not everybody else in the entire class has to fix it for you. Dun, 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 dun. Okay, so what was the first thing after that we needed to do? We need to set up a project. All right, so I'm going to go ahead and do that. Let's see, I'll make a directory that is g102-db. Touch app.js npm init -y git init. Cool, we got an empty git repository. All right, so we need to go to GitHub and create a repository for that. So we're going to create a new repository, call it g102-db. Description, I'm going to leave that blank for now. Create repository. Take this thing right here. Here, let me blow this up for y'all. Go back to my terminal. Git remote add origin that. Can y'all see that okay in the back?
Oh yeah, sure.
Okay. All right, great. So is this line of code foreign to anybody? First off, adding remote to your Git repository. No? You all good on that?
Yeah.
Cool. All right, how do I check what my remotes are again? Git status. Nope. Git log. Nope.
Git remote-v.
Yeah, git remote-v. There we go. Okay, so I've got my remote in there. And you just want to make sure whenever you run something, like in the terminal especially, it doesn't really give you any feedback. It just goes to the next line, right? And you're like, okay, it did something, but did it do what I want it to? You can always check that. To check your remotes, git remote-v. Cool, so now we've got our app.js, we've got a package JSON. Let's go ahead and open this in VS Code. I have to do that again. Cool. Get rid of this welcome window. So what was next? We've got our Git repository set up. We've got an app.js. We've got our JSON file. What do we need to do to make an Express server? Install Express. Dun, dun, dun. npm install Express. Cool, so we've got Express. So the first thing I need to do is require an Express. Come on. Whoops, I did that backwards. Oh yeah, variable for port. Process.env. Jeez Louise. env port. Or 3001. Okay, any questions so far? Basic Express app. We don't have a Git route or anything, but like when I run this, oh, actually, I don't know if this was in the instructions. We need to make sure that our main is app.js, and then we have a start script. Does anybody know why? Why do we need a start script?
So you can start it.
Run test, so you can use npm start in the terminal.
So we can use npm start in the terminal so that we can start it. This is the most important thing for actually when you deploy to Heroku, because Heroku is looking for a start script in your package.json file. If it does not find one, it will not run and it will be broken. So I think I left that out in the instructions, but that is a very important step. Cool, so we've got a listen. Let's do an app.get as well.
In your instructions, you said to put the app.get below the app listing.
Yeah, I think that is the correct way to do it.
I don't know, like every time that we've ever done build version, we put app.listen
At the very bottom.
Yeah.
So like the thing is like your requests are falling through each of the routes. So I'm not sure. I put it at the top generally, but I don't know, Spencer, has it made any difference to you whether you put app.listen at the top or bottom?
I would press the bottom.
Okay, we can put it at the bottom. Sure.
I guess it doesn't matter.
There's definitely going to be a case where it does matter, but in all of my experience, I've never had an issue with anything regarding that specific thing. So then let's res.send. Hooray, I work. Node mon. Cool, listening on 301. So we know our thing's working. Let's test this route real quick and make sure that it's working. Localhost 3001. Res.send. Hooray, I work. Woo! Express. Cool. All right, what was the next step? npm install Knex PG. So these are just getting the dependencies in our project, right? Importing the Postgres library and the Knex library to make sure that like we know what we're using. Dun, dun, dun. Okay, installed. What was the next thing?
Create database.
Oh yeah, that's true.
Database name, that makes sense for g102. It's underscores, but.
Yeah. Student, DB. Cool. Done. Knex. Init. Knex file. Hooray. All right.
I had a question.
Yes.
So when I ran Knex and it, Zish didn't acknowledge command.
Did you install it inside of your project directory?
Yes.
Yes.
Yeah. I don't
That's
run
true.
npx Knex in
Really?
it. Yeah.
Huh.
That's the stack overflow. That's right.
I have never run into that.
What was the command you ran to get it for?
I installed it globally.
Thank you, Greg.
That's all I did.
Just npx Knex in it.
I did dash
I can just slide out.
Huh?
You have to install it locally to use Knex.
Oh, really? Huh. Today I
If
learned.
you use anything in the command line that's like npm, you can install locally, you can say npm something else. Knex, it'll say connect something else, and actually install Knex.
All right.
Do connect install.
So that was my bad. Just to be clear about that, you need to install Knex globally to be able to use that command in the command line. Cool. Today I learned. So we have initted our Knex file. What is our client for development? Using Postgres, right? PG. Connection, we don't need this file name. We were doing, what was it, PostgreSQL : //localhost / g102 student DB, I believe. Cool, so that's all we really need for development. For production, our client is going to be PG again, because that is the library that we installed. And our connection needs to just be process.env.database URL, I believe. Somebody double check that. Dun, dun, dun. Okay, and then we're going to talk about why these are the two things. So we created the database, localhost Postgres, cool connection, process.env.database URL. Okay, so the client part is pretty self-explanatory. We're using Postgres. That is the library we installed. That is the type of database we are creating, right? The connections are a little bit more confusing. So on your local machine, Postgres is running in the background. Brew is running that all the time. So when you're connecting to it on your personal computer, this is kind of the address. It's Postgres, and it's serving via localhost and then the name of your database. Right? It is going to be this same format every time for when you run it locally on your machine. Whereas in the production, right, we don't have a staging because we're not using 3 different environments. We're either local on your development, which is your computer, or we are deployed to Heroku and is in the production environment. The reason that this connection is the way it is, environment variables, variables that are like hidden from your code pretty much, but they are running like on the actual machine. So you can have like an environment variable file on your local machine to store these things, but Heroku actually has these things stored up there. So I'll show you where they are.
Can you slack out that code that you just wrote then?
Yeah.
It's supposed to be in the Knex file?
Yep. Dun, dun, dun. Which one of these has a database?
Okay.
Maybe this one. Settings. Nope. So what I'm looking for is this section called, what is it called? Overview resources, deploy. Config vars, there we go. And as you can see here, this is my deployed database, and Heroku has a database URL config var built in. So this is the address that it will go to every time. And Heroku will always create that for you, so you don't need to worry about it, but process env is looking for these variables that are stored on the server itself, not in any code you've written. Have y'all ever seen environment variables before?
No.
Okay. So that's basically what it is. It's a hidden variable because sometimes you'll store like your API keys in an environment variable, because if you don't store that in somewhere that is like secure and kind of not within your code, people can use your API key to make infinite calls to AWS and charge you $10,000. Happened to somebody in my class. Like for a lot of the lower end APIs that you're rate limited and there's no money associated with it, and you're making calls like your API key is included in the URL you're fetching from, like it's not a big deal. Like don't trip about it. But for a lot of the more robust APIs that people use for enterprise stuff, your keys need to be hidden so that other people can't use them and then get you charged a lot of money. So they're called environment variables, and they are running in, like you can create environment variables on your computer in the terminal. It has a bunch that are already running. Does anyone have any questions? That's still kind of a vague concept, but just roll with it for now. It's mainly for deployment. You don't really need to do anything on your development server with that. That's also why in our app.js, we're using process.env.port. Because y'all have typed that on your other Express apps, right?
No.
I heard yeses and nos.
No.
No? Nobody?
Today's the first time I've seen that.
Oh, wow.
Yes.
You have. So this is, what's that?
In order to deploy your database, you have to.
Correct. In order to deploy your server or your database, you have to. Because if you are telling Express to only listen to port 3001, like that port's probably not open on Heroku. right? On your local machine, you're controlling that. But when you put it onto Heroku or any sort of like hosting service, like they are going to dynamically assign you a port. And if you say you can only listen at port 3001, it's not going to run. Most likely. Sometimes it will. Sometimes that port's open. But that's why you use this process env, because port is assigned by whatever hosting service. Right? So whenever you see this, just know that it is something that is being dynamically assigned by the host. Questions? More?
So we just put or whatever we want to look at it on.
Right.
Okay, I have no idea how to do that. This freaking new.
Cool. So, and the reason we do an or, and the reason we do it in this order is specifically because if it looks for port 3001 first, it will find it. Right? But if it looks for this process, this environment variable first, and it doesn't find it, it's like, okay, cool, I will just use 3001. Does that make sense?
Yeah.
Cool. All right, so we've got our Knex file. I slacked out that code. Remember, we only have the two environments we were working in, development and production. Where is development? What is this running on?
Your machine?
Yeah, it's running on my machine. Cool. Production?
Server.
Whatever URL we get.
Well, it's running on whatever hosting service we're pushing it to. In this case, it'll be Heroku.
Yep.
Cool. All right.
Password authentication for development.
Oh, Windows.
Time.
Um,
Can't really put it in the file.
right. No, I think that I worked through this once before. Spencer, could you? It's you got it.
Yes.
Because like in the basic config, if we undo all of that, it's got this data name, username, password.
Conrad?
Yeah, I did this with Conrad. I forgot what the exact thing was, but like you have a Postgres username and you have like it'll be like probably your root password, but maybe it'll be your user password for that specific account you're on that you installed it under. So like try both of those, and you do have a database name already, right?
Should I then exclude the Knex file from my Git repository?
Yeah, in a git ignore.
Yeah.
Yep. So try that out, and then we can reconnect in a little bit. Okay, now I'm gonna redo all that. Okay, remember, development is on your computer. Production is on Heroku's servers. Okay, and it will know which to do, and we'll walk through that in a minute. Because like, how do we decide which one of these we're using? Right? Because as we move forward and we set up Knex and Postgres together, like we need to tell it which environment we're using. Are we using development? Or are we using production? Because depending on which one we're pointing it at, it's going to try to use a different way to access your Postgres database. Questions? We all tracking?
Yeah. At this point, are we just like watching you do this? 'Cause there's, yeah, I lost you a while back.
In terms of like,
Doing our own.
okay, yeah, that's fine. I mean, all the instructions are there. Admittedly, I messed up on the Knex globally. Forgot I installed that on my computer a long time ago and never thought about it again. But all the instructions you should be able to get through this. There's lots of code snippets and stuff in there.
Can you post the video?
Yeah, absolutely.
I think that'll help.
Absolutely. Cool. So we have got our connections. We're trying to add, commit, push. Yeah, that's probably a good idea. I haven't done that yet. Git add everything. Dun, 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 dun. Ooh, I don't want to do that. Touch, git ignore. I don't want no dang node modules in here. Basic, let's say created basic express app with Knex file included. Oh, yep, got all of them anyway. Git push origin master. Dun, 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 dun. So, as you saw, that got all my node modules. So I added everything before I added my git ignore. The way that I like to take care of that, which is not the best, but it works, is I'm just going to delete my node modules. And then git add, git commit, remove node modules. Go ahead and push it again. Now, the next time you npm install, that folder that has your node modules in it will be ignored. So, because we need those to run our project, but like we don't want all 30 megs of them on our GitHub every time. Cool. So we've configured that. Now let's make a migration. Knex migrate make. We're going to call this students. Yeah. I love it when it's green. No, generally there's not a problem when you make a migration, but running migrations often has some issues. Okay, so now we have these two functions that it has made for us, right? We have exports.up and exports.down. So there's two things you're going to do with this file. You're going to create a table in a schema, and you're also going to drop that table. Right? So if you make changes, you want to drop the table and then remake the table. Now, you don't want to just try to run changes on top of it every time. You want to drop the table, remake the table. So exports up is to make it, exports down is to drop it. This is a table, this is not the database. But if you do run a rollback on your deployed table, it will drop that table. So just be aware. On your development server, it shouldn't matter at all. So Knex syntax. So within these, we always want to return Knex schema create table. So we're taking Knex, the library. We are using this, going into the schema object and using the function create table. So if we wanted to, I'm sure in here we could cons Knex equals require Knex, and then let's see if we can console.log Knex.schema. Let's see what that gives us. Ooh, undefined. Y'all aren't necessarily supposed to be coding along with this. Yeah? Okay.
Are you recording this?
Yep.
Sweet, thank you.
Alright. Anyway, we're going into the Knex object. We're going into the schema and using the function create table. If we go to the Knex docs over yonder, we've got a schema builder. And you can see that this is the way that it's written. Let's blow this up a little bit. Alright, creates a new table on the database with a callback function to modify the table's structure using those schema building commands. Because remember, what is a schema? Sorry? The blueprint, the skeleton. This is what data types and what column names we're going to be using, right? So this is where we actually create all of those things. So again, Knex docs are your friends. Cool. So we're returning this create table function. What should we call our table? Students. Studnets. Students. All right. And then what each specific entity is going to be is what you're going to pass in here. Doesn't matter what you call it, but like call it something that makes sense. In this case, we have a table of students, so what should one be called? A student would be the name of our specific entity. So student. So in here, we have our callback function that is actually going to create those columns, right? So what does every specific entity or every entry into our table need? An ID, a unique identifier. So we'll do student.increments, and we'll say that it's called ID. All right, what was the next thing in the object? Well, student.string name. Next. Face animal, fave animal. Oh, I keep doing this. Student.string fave animal. Cool, what's next? Student.string previous occupation. Next. .int hometown lat. And if you're ever confused about these types, like what are the types that we have access to? Guess where you can look? Over here in the schema building docs and Knex. Like it has all of the answers you need here. So we have decimal, we have float, we have,
What does integer consist of as far as?
let's check it out, as an integer column.
Okay.
Doesn't really tell you. It's just, this is for a number.
Because for Denver, it's like a negative longitude.
You should be able to enter negatives. Yeah, for sure. Good question. All right, so what was next? Is that all of them? Student.string useless superpower. Cool. That's all of them? Great. Right, the syntax is like pretty straightforward. It looks weird the first time you see it, but this is the hard part right here. This Knex.schema.create table. You do it enough times, you won't have to think about it. But now you just need to remember that exports up is creating your table, and exports down is dropping your table.
Got it.
Cool. So in our exports down, we're going to return Knex.schema.drop table if exists. What's the name of our table again? Students. That's it. So let's see if it works. To run our migration, to create our tables and schema, you do Knex migrate make latest. There we go. Oh no. Type undefined does not exist. Failed error students ID primary serial key name varchar 255 previous occupation hometown lat undefined. Whoops. Well, that gives us a pretty good clue as to what happened. Can anybody tell me what I did wrong?
Is it expecting an
Int is not a data type. Let's go back if y'all can see this. Integer. Right? Int wasn't correct. We need to write out integer. So let's try that. Integer. Cool. Like, it's okay if these things don't run, just read the error messages and you should be able to figure it out. Let's try it again. Woo! Green! Sweet. So if we wanted to see this, how would we use Postgres? If y'all remember from Sean's lesson about going into your databases. If we just wanted to look at this, right? We see that it ran, but how do we like look at it and make sure that it did what we want? PSQL. What's the name of our database? I don't remember what I named it. Yeah, mine's different.
Something students.
Uh,
102
/ oh, that's a good point. G102 student DB. Oops. Okay, that's all of those. /D. Okay. Select star from students. Oh. Does anybody remember this syntax? Right? Select star from students. That should get it, but there's actually nothing in there. I just want to see. Ah, there we go. What did I do wrong? Guess they need to be caps. Cool, so there we go. There's what our table looks like right now. We have created a migration. We have run that migration. There we are. Questions? That's a lot of information. There's a lot of steps to connect Knex and Postgres together, right? But it's not that bad. This is, so far we have 3 files that we've been working in, right? We have our app.js, our Knex file, and now we have a migrations file. And this, the format of the migrations file, will always make this exports up and exports down for you. So when you look at it, you'll be like, okay, what does exports up do? Trey, what is exports up for? What is exports up for?
To bring the database out.
Right, to build the table in that database, right? And Connor, what's exports down for? To populate it? Exports down is to drop it. Is to get rid of it. No, you're good. Does everybody have that clear? Exports up is to create the table and the schema. Exports down is to drop it. Okay, this file will always have those 2 things in it. It is a file that you use with, like, Knex will create it for you.
So dropping is that?
Doesn't just remove the column, it removes the whole table.
Right, and we would do that whenever we make a change.
Right.
To the current table.
Right, so if I were to do like student
So
dot,
that's so a change in that sense of adding a column versus a change into adding a student to it or an entity to it.
if you were to add an attribute to this entity, right, because the entity is kind of the idea of the table and the attributes are each of the things that it has. If you were to add an attribute to it, I would roll back your table, drop it, and then push it back out. So that'll look something like this. You do Knex, migrate, roll back. And it's like, cool, rolled back your migration. That drops the table. Now if we did PSQL G102 student DB and did select star from students, relation students does not exist. Can y'all see that okay? That's pretty small still.
So,
Yeah.
are you controlling the students dropping up and down to the terminal?
Yep.
Okay, so that's what's happening.
That command I ran, Knex migrate rollback, that is the command for Knex to run that exports down function.
Okay.
Does that down function ever actually change?
You change it, but like this is the way that I always write it. I'm sure there's use cases for other things, but every time I do it, that's the way it is. Its sole purpose is to drop that table so that you can then create it anew.
So you're just using the terminal to manage the data now in the database, pretty much.
Not quite the data yet. So we're still just like creating the organization for the data so that it is kind of presented as information to us and it makes
Is that
sense.
the goal, though, to manage the data from the terminal?
It will be to create the database, create the tables, and create the seeds, which is kind of the initial data from the terminal. right? You will run those files from the terminal, but you still have to write the code in them and stuff. It's a lot of information, I know. Bear with me. Okay, I'm going to zoom out a little bit because I can't see now. Okay, so we have rolled back our migration. We have checked again to see if students is there and students is not. Why? Because we rolled back our migration, we dropped that table. Cool. So I want to put that table back into place. What do I do? Knex migrate latest. Correct. Nice. Lastest. Nope, latest. Woo! It runs. Okay. This makes me very happy. As these things get more and more complicated, this is like the best thing ever. Yes. All right. I actually don't want to know how much money anybody has. I'm going to delete that out and just roll back again real quick and remigrate. Knex migrate rollback. Knex migrate latest. Cool. Green all around. I'm going to push to GitHub now because we have a thing that works. And whenever you have a thing that works, you should probably push. Right? Cool. Because at least that way, if you break something, you can revert back to something that you know for a fact works. So git add, git commit, added migration for students table, git push origin master. Hooray. All right. So before we move forward into the seeds, does anybody have any questions? Okay. So to create seed file, one more time. What are seeds again? Placeholder data, right? This is stuff that we're going to put in our database so that we can see if our queries are returning what we want, or we can make sure that the front end is like being able to consume the data, or give it to somebody else and be like, hey, does this make sense?
And then it's placeholders for specific entities, right?
Yep, exactly. It's placeholders for specific entities. So we're going to create a bunch of specific entities to give our database. So to get that folder and file, we do Knex seed :make. We're going to do O1 students. So I wrote this in the instructions, but I did not talk about it. You see this long line of code right here? These numbers? It's not really a long line of code. What does that look like to y'all? It's a time date stamp. So if you have multiple tables, those migrations will run in basically alphabetical order. But since it's a timestamp, that is the part of the alphabet that's going to be primarily running off of. So the thing you make first is going to run first. The thing you make second is going to run second. You want your seeds to run in the same order. So when you name your seeds, they need to be like O1, O2, O3, so that you can specify kind of what order they will be run in. This becomes an issue when you have relations between tables, because if a table has a relation to something that doesn't exist yet, it's going to break. So you need to keep that in mind. It's not going to be important for this specific project, but just know that your migrations and your seeds run in basically alphabetical order. Okay? Woo!
So is it numeric order or alphabetic?
It's alphabetical, but like it's looking at numbers and it goes to like the smallest number first.
Okay. So is it numeric alpha or alphanumeric? In the sense of prioritization, like we'll go
Numeric
through,
first.
So it'll go through 1 through whatever,
And then it'll go through the numbers. Or sorry, numbers first and then letters.
Okay.
Yeah. Good question. Cool. All right, so we have our migration. We have this table thing. We know that worked. We looked at it. Now we have this seeds file. All right, so looking at this, we have exports.seed as a function with some stuff in it. The first thing that it does is what? Right, so when you run your seeds, it's going to be like, all right, whatever data is in there, delete it. and then insert this data, right? It's to go back to a starting point for your seed data. If you get a bunch of trash in your database from a bunch of your friends putting random stuff in there, and you want to go back to where it was because what they put in was offensive, run your seeds again. It'll wipe everything out and put in just what you had specified before. Then, so it does this, and then it does this. It's kind of like an async thing, but it's now like synchronous. It's running in order. So then function, and then this is what inserts the seed entries. Right? We just have, it inserts plain old objects. But we need to change two things right off the bat because this is wrong. What is the name of our table? Students. Hooray. Okay, so this is the file that we're going to take. Where's Slack? And where's a thread? There we go. All right, and then we're just going to take these things and plop them in. So first one, yeah. What? Oh yeah. That was very confusing.
It has the word number of those integers.
Oh yeah.
Yeah, and it goes in this
Format these right.
Sorry.
Okay, I think that did it. Yeah, alright. Cool, so that's one. I'm not going to do all these. I'm going to do one more though. Dun, 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 dun. Here. Let's see. So that's good, that's good. Don't want that. Don't want that. Alright, that's two objects in there. This is the way they should be formatted. If you want to use double quotes, I don't care, use double quotes. But the keys need to be like they would in a regular object. And numbers do not need to be quoted. Make sure that your quotes are the same all throughout. Yeah, what's up?
Did you need to keep the ID on each one, or did you take the ID out on purpose? There was an ID before the name.
In the initial seed data?
Yes, sir.
Yeah, that's a great question. So when we set it here to increments, like it will automatically add that and start at 1, and then go to 2, and 3, and 4, and 5, and 6, all the way down. You can insert that in the ID, but there's another line of code that you need to make sure that this increment starts after your seed data.
Right.
So like if you have 4 seeds, IDs 1, 2, 3, 4, you need to make sure that this increments will start at 5.
Your dog's out there running wild.
I know.
Cool. Well, as soon as we finish like getting this seed file, which we're pretty much done here, we're gonna take a break. Y'all can work on it by yourselves, get some food, drink some water, go outside, smoke a cigarette, whatever you need to do to kind of decompress a little bit to come back to this, because this is a lot of information. Okay, so we've got our things. We're going into our table students. We're deleting everything, and then we're inserting all of our seed data. Right?
Right.
I don't see any syntax errors. Great. Let's run it. Knex, seed, run. Oh, boo. Invalid input syntax for integer. Okay, cool. Right? That's not that bad. Right? That's a good error to run into. Like, we can fix that. So, let's go back to the Knex docs. Decimal? Cool. Decimal. This is really big. And then it has two optional arguments for precision and scale. The optional precision defaults to 8. I think we should be okay with that. So let's go back to our migration. Decimal. Decimal. Great. So now what are we going to do? Roll back.
Roll time.
And then we're going to migrate latest. Still works? All right, seed, please run. Connect, seed. Zeed. Seed, run. Woo! It worked! So how are we going to double check this to make sure that it works so that we can see it? PC, I'm just going to go up, yeah. PC equal g102-DB. Select star from students. Yeah. All right, well, that's confusing looking. I'm just going to come over to this terminal. PC equal g102 student db. Yeah. Select star from students. Yeah. Still confusing. Whatever. We have data in there. Look at it go. Doesn't look very pretty, but those URLs are super long, so you know, what are you gonna do? But it's there. All the stuff we put in there is there. It's there. It's really there. So we're gonna take a 10-minute break, reconvene at 11 o'clock, and we'll write our first query. Okay? Cool. Get to it.
Not every. I just had to re-download Homebrew and all that stuff. Yes? Yes, ma'am.